So then we use deductive reasoning to come up with an experiment to test the hypothesis. So what could we do? Our hypothesis is sunflowers always face east. Well, let's just double check they face east always at all times during the day. Well, so I go and look at them at 8 o'clock in the morning facing east. I'll go ahead and look at them at 4 o'clock in the afternoon. They're facing west. That means that the hypothesis, sunflowers always face east, can't be right because part of the time they're facing west. So our hypothesis, our potential explanation for this phenomenon of they all face the same direction because they're all facing east, well, that's wrong. Our hypothesis is wrong. We have figured out that our idea is wrong, and this in science is absolutely brilliant. This is what you want to do. You came up with an idea, you tested it, you figured out it wasn't that, and now we're going to go on to something else. All right. So now we've got to come up with another experiment. How are we going to figure out if all the sunflowers face the light? Well, sunflowers are kind of big and they're slow. They take all summer to bloom. So this is where we're going to use a model organism. And a model organism is one that retains as many characteristics of the system as we can have, but has really nice properties. So for example, this is Arabidopsis. It's a plant that we use a lot in biology as a model plant. And what's really nice about it, it will go from seed to seed in less than a month. So it reproduces really quickly. These are small. They'll get to maybe 18 inches high as opposed to many, many feet from the sunflowers. They're easy to grow indoors and they're cheap. So these are really nice model organisms because they're really easy to work with. And since they're a plant, hopefully they have a lot of the same characteristics as a sunflower. So now we have to come up with an experiment to determine, do we think the Arabidopsis always faces the light? And one thing we like to do when we're making an experiment is to make sure that there can't be something else that's causing the experiment to happen. So for example, we don't want the temperature to be changing during the day. We don't want the number of plants around them to be changing. We want to isolate our variable to whatever we want to test. So in this case, we're putting these plants in chambers. So basically this is sort of like a box that you can put a plant in and you can put a light source in. And a lot of them have a lot of mirrors in them so the plants get as much light as we can get. But we want to put the plants in an isolated space so we can hold everything else constant and let them look at the light. And what we want is to always have a comparison between two groups. So one group is going to be called the control, and that we're not going to mess with. And the other group is our experimental group, and we're going to change something, change one thing in that group. So in this case, we're going to say face the light. Well, one is going to have a constant illumination source all the way around it, and the other group is going to have a light that slowly moves back and forth. And if the sunflowers follow the light, well, that's pretty good evidence they face the light. Is that conclusive? No. Why not? Well, one, we're working with Arabidopsis, not sunflowers, so it's always possible that Arabidopsis, this little white plant, does something different than the sunflowers. And it's also possible that maybe it's not light that's the issue. Maybe it's something else. So for example, maybe they're not following the light, maybe they're following the heat. Why do we need the control? Well, maybe the sunflowers are just flopping around during the day. They flop east to west during the day, and they do that regardless of light. They're doing it because of the spin of the earth or something weird, right? We don't know, but we need something to say, okay, it's not just happening all the time. There's something that changes when we have light as compared to no light. Another example of this is if you had a glass of soda. You open the soda, it goes psst, and you get all those wonderful fizzy bubbles and you pour it into the glass. Well, I leave my glass on the table overnight and all of a sudden I don't have wonderful fizzy bubbles anymore. And I could say, well, glass takes all the bubbles out of soda. But what we know is it wasn't the glass that took the bubbles out of the soda. It was the fact it was not under pressure anymore, and now the carbon dioxide could escape because under less pressure, the CO2 bubbles out of solution. But we wouldn't know that by just putting a glass on a table and leaving it there overnight. It would be perfectly reasonable to say, oh, it's the glass that got the bubbles out of the soda. So what we need is a glass container and maybe a plastic container, and we find out they do the same thing, so then it's not the glass that's the problem. All right, so we always have a control. Experimental design, be like my friends. So what do we mean by be like my friends? That means all the sunflowers are doing what their nearest neighbor does. So how could we test this? Well, we could turn a sunflower around, right? So in one group, you have one sunflower turned around compared to all the others. In the other group, all the sunflowers all face the same direction, and we can see what happens. Does that sunflower turn around? Do the other sunflowers turn around? So we can see what changes. So what was the control in this group? Well, maybe the control was a group that they were all facing different directions. Maybe there was a control where they were all facing the same direction. There's a lot of ways you can do a control, and actually one of the big things that people argue about was whether your control was actually good enough. And remember, control is just a experimental condition where nothing's changing.